When we think of the car today, it's easy to forget just how new cars are in the grand scheme of things. The first quadricycle was invented over 200 years ago, but aside from those early days, the design of the modern car has only been around for roughly 100 years, and this form hasn't really changed much since then. Some features have been added, like cup holders and heated seats, but the general shape of the vehicle has remained largely unchanged. But that wasn't always the case. In fact, if we rewind time just another 50 years, you'll see that the vehicles being manufactured looked vastly different than they do today. So how did we go from these boxy-looking cars to the sleek designs we see today? Well, that's what we'll explore in this video. For the sake of simplicity, we've split this video into 4 major shifts in manufacturing that led us to today's cars. Let's start with the first one, steel. It all begins with the invention of a material called steel, which actually goes back hundreds of years. Steel is created by taking iron ore and mixing it with carbon and other elements. This makes the end product stronger and more durable. However, it also makes it significantly more expensive. For most of human history, this was too costly for common folk. But all of that changed during the American Civil War, when new steel manufacturing techniques drove down costs. Suddenly, everyone could afford steel products, and the world would never be the same. One man named Henry Bessemer saw an opportunity. He realized that this new, cheap steel could be used to build bridges, buildings, and most importantly, cars. This is why steel is often referred to as the backbone of the Industrial Revolution. It allowed for innovations and efficiencies that led to many of the developments that we take for granted today. Prior to steel, most cars were made out of wood. Yeah, wood. That's because before steel became cheap enough, wood was one of the only materials available that could be mass-produced and be strong enough to serve as a frame for the vehicle. Of course, wooden cars weren't exactly safe. They were terrible in the rain and prone to spontaneous combustion. You can probably imagine the look on someone's face when their car bursts into flames. Not good. But even after steel replaced wood, it still took some time for manufacturers to figure out the best way to use it. One of the first challenges they ran into was the fact that steel is heavy. When they began building cars with steel frames, they quickly realized that the weight of the vehicle was making it difficult to keep moving. To fix this, they turned to a process called stamping. Stamping is a technique where metal sheets are placed between 2 dies, which are then pressed together, forcing the metal into a specific shape. By using stamping, manufacturers were able to create lighter gauge steel parts without sacrificing strength. For example, the roof of a car isn't going to experience the same forces as the frame. Therefore, it doesn't need to be as strong. So by using thinner gauge steel, they're able to reduce the overall weight of the car without compromising safety. Another challenge had to do with the manufacturing process itself. Turns out assembling a car from scratch was quite labor-intensive and required dozens of workers. To improve efficiency, one engineer named Ransom E. Olds came up with the idea of the assembly line. His goal was to create a system where cars would be moved from station to station with workers performing the same operation at each stop. This increased production while reducing the amount of time it took to manufacture a single vehicle. Today, however, this process is mostly automated. Robots perform the exact same action at each station, making the process faster and more efficient than ever before. All of this combined led to the creation of today's steel vehicle frames, which are safer, lighter, and stronger than ever before. Now that we've covered steel, let's move on to the second shift, electricity. You see, while steel provided the structural integrity needed for a vehicle, it was the introduction of electricity that brought cars to life. Up until this point, cars were primarily driven by steam power. Basically, steam power worked by boiling water, which creates steam. Steam would then be released into a cylinder, forcing a piston and turning a crankshaft. This would then transfer power to the wheels, driving the vehicle forward. But there were significant drawbacks to this design. For starters, you need coal to produce steam, which obviously adds extra weight to the vehicle. On top of that, it also requires frequent stops for refueling, but perhaps the biggest drawback was its unreliability. Steam engines were notorious for breaking down, leaving drivers stranded on the side of the road. This is why the invention of the electric motor was such a big deal. Not only did it eliminate the need for coal, but it was also much more reliable and easier to maintain. While it wasn't as powerful, it didn't require the same level of power to operate. This is why early electric cars were so small. Their motors were only capable of reaching speeds of up to 20 miles per hour. But even so, The advantages of not having to refuel and the lower maintenance costs attracted many customers. As the electric motor improved, so did the size of the vehicle. Then in 1930, General Motors unveiled a concept car that could reach speeds of up to 120 miles per hour. Fortunately, the Great Depression hit, and people had other things on their mind. GM scrapped the project, and the focus shifted to cheaper, less luxurious items. But regardless, the electric motor paved the way for the third shift, the internal combustion engine. When most people think of cars, they're most likely thinking of the internal combustion engine, or ICE. The reason for this is that the ICE has become synonymous with the modern car. In fact, it's estimated that over 2 billion ICE vehicles are on the roads today. But it wasn't always this way. In the early days of automobiles, there were three main competing methods of propulsion: steam power, electric motors, and the internal combustion engine. At the time, steam power was seen as too slow and cumbersome, while electric motors were considered too weak. This left the internal combustion engine as the obvious choice. However, there was still one major drawback. Internal combustion engines were extremely inefficient. They lost about 75% of their energy to friction and other inefficiencies. This meant that for every 100 units of energy put into the engine, only 25 units were converted into power. But one German engineer named Carl Benz solved this problem with a simple addition: supercharging. Supercharging works by forcing more air into the engine, allowing for more fuel to be burned. This improves efficiency and allows for more power to be generated. While it's been around for over 100 years, supercharging has evolved quite a bit. Early superchargers were belt-driven, but today they're powered by an electric motor. This allows for better control over the amount of boost pressure being applied. On top of that, newer technology like twin charging and variable valve lift further improve efficiency and power. All of this has led to the internal combustion engine we know today, which is much more efficient than ever before. But there's one last thing that we need to cover: aerodynamics. See, up until this point, the focus was on improving efficiency and power, but no one was really looking at the actual design of the car. No one thought much of it because back then, the heavier the car was, the more power it needed to get moving. So it made sense to make them as boxy as possible. This gave them the maximum amount of space while requiring minimum amounts of energy to move. But once the internal combustion engine was perfected and fuel became more readily available, the focus shifted to aerodynamics. The first step in this direction was to reduce the amount of surface area while maintaining the same amount of interior space. This is why the tall, boxy shapes were replaced with more rounded designs. As engineers got more familiar with aerodynamics, they started testing wind resistance through wind tunnels. One of the first companies to do this was General Motors. In 1930, they built a wind tunnel that was 8 feet tall and 20 feet long. They then tested various shapes and designs to determine which one had the least amount of wind resistance. What they found was that a teardrop shape was the most aerodynamic. In order to achieve this shape, manufacturers had to redesign the entire body of the vehicle. They started doing this by smoothing out the edges and adding more curves to the body. This reduced the surface area while maintaining the same amount of interior space. But they didn't stop there. They also redesigned the grille and bumper to improve airflow. These changes might seem minor, but they had a significant impact on fuel efficiency. In fact, just by changing the shape of the grille, fuel economy can improve by as much as 10%. Today, automakers spend millions of dollars on wind tunnel testing. If you look closely at the latest vehicle designs, you'll notice that they have smooth contours, tapered rear ends, and low profiles. All of these features are designed to reduce drag and improve fuel economy. And that's how we went from clunky, unsafe, and inefficient wooden quadricycles to today's sleek, high-powered machines. Oh, and don't forget to check out our video on how computers made driving safer and more enjoyable. Thanks for watching, and we'll see you in the next one.